All right, today we're going to look at a completely different way to think about artificial general intelligence, AGI. It's a perspective that says maybe we're focusing on the wrong things, that it's not about more data or faster chips, but about reframing the entire problem.
So let's kick things off with a real head-scratcher. How is it that just a handful of human thoughts can somehow beat a supercomputer churning through 1 trillion computations? Our minds can feel kind of slow, even clunky sometimes, and yet we can solve problems in a few steps that can totally stump some of the most powerful machines on Earth. This is the efficiency paradox we're going to unpack today.
And here's that paradox laid out bare. On one side, you have the human mind. At a conscious level, it's pretty slow and simple. We think in these big, high-level patterns. One idea just kind of flows to the next. On the other side, you've got a supercomputer. It's all about raw speed, insane complexity, and crunching tons of low-level data. And yet, our approach so often wins. So, what gives? Well, the answer seems to lie in 3 really big core ideas.
Okay, so let's get into our first pillar. And this one is a real game changer because it completely flips the script on how we normally think progress happens. It's all about putting creative ideas, not raw data, in the driver's seat.
This brings us to a concept called Popperian problem solving. The key takeaway here is that progress is an active process. It suggests we don't just passively learn from data like a sponge. No, we're out there actively creating new ideas, new explanations. And then, and this is the crucial part, we do our absolute best to tear them down, to criticize them and to test them until they break.
And you can really see the massive difference here. The mainstream view of AI is that progress comes from a data-driven engine. You just feed the machine more and more data, and it spits out a better model. But this Popperian view says the engine is totally different. It's a creative trial-and-error engine. You generate an idea, then you criticize it, and you just repeat that cycle over and over.
A great way to think about this is evolution. Evolution doesn't have some grand plan, right? It isn't trying to solve the problem of how to create a human. As the quote says, it's just a bumbling fool. It's trying out random variations and just seeing what happens to survive. Progress happens through that simple process of variation and selection, not by solving for some specific goal.
So you might be wondering, well, what's a problem even for then? And that's a great question. A problem acts like a powerful focusing lens. It takes all that bumbling, random creativity and just aims it. It dramatically narrows down the infinite number of things we could be trying and focuses our creative energy. It also gives us a clear target to shoot at when we're criticizing our own ideas. It makes that whole bumbling process incredibly efficient.
All right, on to pillar number 2. And this one challenges the very idea of what intelligence even is.
This is a concept called universality. And the big idea here is that intelligence isn't just a smooth ramp that you climb from dumb to smart to super smart. Instead, it seems to involve these sharp, massive leaps in what you're capable of doing. Think about the jump from a simple pocket calculator to a universal computer, a machine that can, in theory, compute anything. That's not a small step. That's a whole new category of existence.
So while the mainstream view often pictures this infinite ladder of intelligence that we can just climb forever, the universal view suggests there's actually a ceiling. Once a system becomes universal, meaning it has the fundamental capacity to understand any explanation, it's reached the maximum type of intelligence possible.
I absolutely love this quote because it just nails the enormous gap we're talking about. We aren't just a little bit smarter than other animals. There's a grand canyon between our kind of universal intelligence and their non-universal abilities. Squirrels aren't making slow and steady progress towards rocket science. They're playing a completely different sport on a completely different field.
And here's the crucial takeaway. Once a system has the universal hardware for intelligence, that hardware is pretty much maxed out. From that point on, the only thing left to grow is the software, all the knowledge you can load onto it. And that knowledge, that can grow infinitely. Okay, on to our third and final pillar. And this one's all about a very unique type of knowledge, the actual fuel that powers this entire system of progress.
This brings us to what's called explanatory knowledge. Now, this isn't just a simple instruction, like a piece of code that says, run away from the lion. No, it's a claim about how reality actually works, like the sky is blue because of how light scatters in the atmosphere. It's a model of the world that you can actually hold up and judge as either true or false. Think about the difference here. A gene is non-explanatory knowledge. It's basically a set of instructions, do this, that just works without really explaining why. A scientific theory, on the other hand, is explanatory. It's a model of reality that makes a claim that says the world is like this, and that opens up a whole universe of new possibilities.
And here's why that's such a superpower. Because once your knowledge starts making claims about reality, you can check those claims against each other. You don't always need to go out and get new data from the world. You can actually find errors just by looking inward, just by checking for internal consistency.
Let me give you a super simple example. Imagine you have two ideas in your head at the same time. Idea A is, the sky is always blue. Idea B is, the sky is always red. See the problem? You've got an internal conflict. An error has just been flagged, and you didn't even have to look outside to find it. This internal check for coherence is a huge engine for progress.
So, let's pull all three of these pillars together. What does this new framework tell us about the real challenge we face in trying to build AGI?
Well, it's clearly not just about shoveling in more data or building faster and faster chips. That's the brute force approach, and we've already seen how our seemingly bumbling but incredibly efficient minds can already outcompete that. The real goal has to be something much more profound.
So just to quickly recap, we're replacing simple learning from data with a powerful cycle of creativity and criticism. We're replacing a smooth, continuous scale of intelligence with the idea of a universal leap. And we're adding internal consistency as a powerful new error signal, so we're not just relying on external data to tell us when we're wrong.
And this, I think, really gets to the heart of it all. The space of all possible ideas, all possible explanations for everything. It's functionally infinite. So the true magic, the real mystery of intelligence, isn't just about how you come up with ideas. It's about how you navigate that enormous search space and do it efficiently without getting lost forever.
So the grand challenge for AGI, from this perspective, isn't about building a bigger brain. It's about creating a system that can do what our minds do every single day, efficiently navigate an infinite space of ideas. The true goal, really, is taming infinity,